everyone, happy Monday. We are still working on some exponentials this week. This will be our last week with exponentials, and then we'll kind of move into, our next unit. Okay, so today we are going to be focusing on whether something is linear, quadratic, or exponential. So hopefully you know what all of those words mean, but we're going to go into a little bit more depth for each one. And then your practice today is some textbook questions that I've taken a picture of my textbook. And you just have to identify whether it's linear, quadratic, or exponential and tell me how you know. Okay? So today's lesson note looks like this. Again, print it off if you'd like or not. So we are first going to look at linear equations. So this is an example of a linear equation, but you might hopefully remember y equals mx plus b. You probably saw that a lot in grade 9, a little bit more in grade 10. Okay, so y equals mx plus b is the equation of a line. Okay, and I want you to make a note here that on the x, the exponent is 1. The exponent is 1. Okay, so that's what an equation looks like for a linear relationship. So in something in the form y equals mx plus b. We're also going to look at tables of value. Okay, so to determine if something is linear from a table of values, we first look at the first differences. Okay, so we take our second y value, which is -2, and we subtract from it -4. So we do y2 minus y1. We get 2. 0 minus, we're going to fill in the chart. -2 is equal to 2. 2 minus 0 is 2, and 4 minus 2 is 2. Okay, so your first differences for a linear relation are all the same. Okay, and that's how you would know if it was a linear relationship or not. If I didn't tell you, you could go to the table of values, calculate the first differences, and see from there. We can also calculate the second differences, which is essentially the same thing, except this time you're taking the differences and subtracting the second one from the first one. So we have 2 minus 2, 2 minus 2, okay, and so it's 0 all the way down. So second differences are always 0 in a linear relationship. Okay, and just like the word linear implies, when you're looking at the graph, it's a straight line. Okay, so linear relationship is a straight line. Awesome, so looking at a graph, at a table of values, and at an equation, we can determine whether it's linear or not. Okay, we're going to talk about quadratics next. I'm going to take a sip of my coffee first. It's like real life, guys. Excuse me. Okay, so a quadratic relationship is anything with a squared in it. Okay, so the actual base equation looks like this. We didn't really talk about this, but maybe you did last year. Okay, but what we want to note here is that the exponent is 2. Okay, so there's a squared always in a quadratic relationship. Okay, let's look at the first differences from a table of values. So we're going 1 minus 4 is -3. 0 minus 1 is -1. 1 minus 0, +1. And 4 minus 1 is 3. Okay, so different from last time. Now all of our first differences are different. Okay, they are not the same. Alright, so then we can go to our second differences and do the same thing as before. So -1 minus -3. We're taking our second number and subtracting the 1 in front of it. We get 2. 1 minus -1 is 2. And 3 minus 1 is 2. So our second differences this time are the numbers that are the same. Okay, so back in linear, our first differences were the same. Okay, and then over here, it's our second differences are the same. That's how you know that it's quadratic. And then from the graph, we've hopefully recognized this shape, right? When we've got a quadratic relationship, it's a parabola. Beautiful. Okay, so that is hopefully some review either from earlier this semester or from your previous math lives. Okay, so linear and quadratic relationships, you have to be able to recognize them from the equation, from the table of values, and from a graph. Okay, this year though, we also have looked at exponentials. So an exponential is in the form y is equal to a times b to the power of x. Okay, this time we are noting that the exponent is x. Okay, that's how we know that it's an exponential relationship. The exponent is your x. Okay, we can also look at tables of value. We always start with a table of values by calculating the first and second differences. Okay, hopefully we recognize something different in this one from before, but we always start here, okay? 1/2 minus a quarter is a quarter. 1 minus a half is a half. 2 minus 1 is 1, and 4 minus 2 is 2. Okay, so the first differences are different. They are not the same. So we're going to keep going and look into the second differences. This should always be your path, okay? So you start with first differences, see if those are the same, because if they are, you know it's linear right away. Okay, but if they're not, we're going to go on to the second differences. Okay, so it's our second difference minus our first difference. So 1/2 minus a quarter is a quarter. 1 minus a half. 2 minus 1. Okay, so this time our second differences are also different. Okay, so if both your first differences and your second differences are not the same number, we can hope that it's an exponential, okay? But we're going to check it out just to be sure. Okay, so remember we talked about the ratio, okay? So your ratio is your y2 divided by y1. Okay, so if we go all the way back here to our y's, we are going to do a half divided by a quarter. Okay, I'm just going to add kind of an extra row here. So a half minus a quarter is, a half divided by a quarter is 2. 1 divided by a half is 2. 2 divided by 1 is 2. And 4 divided by 2 is 2. Okay, so our ratios, what are they? They are the same. So that is how we know it is an exponential function. Okay, but the way we go through it is always the same. We check first differences first, then second differences, and if those still aren't the same, we've got to just double check to make sure the ratios are the same so that we can, with certainty, call it an exponential. Also, we looked at some graphs, and we're going to look a little bit more at graphing tomorrow, but the curve line here shows that it's an exponential. It could also be a curve going the other way, right? So we looked at both exponential growth and decay. So it's a curve that is always increasing or decreasing. Okay, so your curve is always going up or always going down. That's how you know it's an exponential from the graph. Okay, so take those three things. Linear, y equals mx plus b, first differences are the same, straight line. Quadratic, exponent of 2, second differences are the same, parabola. And exponentials, where the exponent is the x, the ratios are the same, and there's a curve either going up or going down. So take that information and try today's practice questions. It's a picture out of a textbook. Okay, and I'll tell you exactly which questions I want you to do. If you've got any questions about those, let me know.